Hello, good day. I am Neil Francis Igabisay with here partner Gabriel Sabang to present our new TechNova new solution for Malaysia new regional office. Here's our topology.
The Malaysia office consists of three buildings: Building A for corporate, Building B for technical operations, and Building C for customer-facing departments. The design uses a three-tier hierarchical model with core, distribution, and access layers, and connects back to Singapore HQ using BGP connection. Starting at the top, I have the external router, which simulates both the Singapore headquarters and the Internet ISP. It connects to WAN router, which is the Malaysia Edge router running as AS65001. So below that are two core switches. Core switch 1 is the primary root bridge and core switch 2 is the secondary. They're connected by a 10G trunk interlink for redundancy. Each core switch has crosslinks going down to all three distribution switches. Each building has one distribution switch, distribution A for this building A, distribution B for building B, and so on. Each distribution switch connects down to two access switches, and each access switch has one PC connected for testing.
And now we will start with VLAN verification. So you can see is we have 12 VLANs configured across the network, one per department plus management and gas VLANs. You can see building A, building B, and building C. All access and distribution, and of course switch 1 and switch 2. So let us check in access A1 and building A1, the access switch serving the building A1. Okay, let's see the configuration over here. Let's start from the beginning. So show VLAN brief. As you can see, VLAN 10, its name is Zach, assigned to Fast Internet 01 through 015. Those 15 ports serve our executive management department, and VLAN 20 is finance. It's in Fast Internet 016 through 024. For finance and accounting, VLAN 99 is our management VLAN, which is also the native VLAN in all trunks. So now let us check the trunk links in the same switch. So all we type is show interference trunk. So show interfaces trunk. So you can see is gigabit O2 is tracking with 802.1Q in encapsulation. The VLAN 99 or native VLAN and carries 10, 20, and 99, exactly the VLANs this building needs. We do not carry VLANs from building B or C in this trunk, which is efficient VLAN pruning. So let us check quickly in access C, in building C. In building C to show the guest VLANs isolation. So we quickly start from the beginning. All we do is enable and show the VLAN brief so we can see everything. So you can see is VLAN 90 is training is on ports 90 to 20, and VLAN 110 as your guess is on ports 21 to 23. Notice that VLAN 110 has absolutely no IP address configured in core switch 1. Guest traffic is completely isolated at layer 2. Layer 2 and it cannot be routed by any internal resources. This is intentionally for security. So now let's check the trunk on distribution A to confirm the uplinks of both core switches. Once again, let's start from the beginning, and we'll show interfaces trunk spacebar so we can see everything now. So Fast Internet A1 and O13 here both track down those access switches building in building A and gigabit internet 01 and 02 are the uplinks going to core switch 1 and core switch 2. Respectively, both uplinks are active. As you can see, very active. Then one build for writing the one will be in STP building blocking state, which will be verified in the next segment. For layer 2 redundancy, we implemented rapid PVST across all switches. So we choose core switch 1, as you can see here, as the root bridge for every villain by manually setting its priority to 4096, which is the lowest possible value and guarantees it wins root elections. Let's click it and configure it. Show the configuration. Enable, show spanning, tree, summary, boom. As you can see, the spanning tree is rapid, and core switch 1 is the root for all active villains. Let us confirm that by directly from the config. So all you do is type this show running config and include the spanning tree. There it is, a one single command. Okay, there it is, spanning tree mode rapid PVS, and the spanning tree villain 1 to 4094 priority 4096. The single command makes core switch 1 the root for every villain on the network. Now let us check in core switch 2 to confirm our redundancy is working correctly. Let us see. Once again, type the show spanning tree command to see everything. First is enable it. Spanning tree, summary. Core switch 2 is not the root for any villain. You can see it has a blocking ports and forwarding ports. Those blocking ports are the redundant uplinks from the distribution switches being held in a standby by spanning tree. If core switch 1 were to fail, these ports will unblock and fuel within few minutes or seconds under rapid PVS here, and the network will continue to operate in true switch 2. It's like a backup for if core switch 1 will fail. So core switch 2 will active. These are core redundancy in action. All access ports, all 6 switches have port and BPDU guard configured, which is eliminates the 30 seconds STP delay for end devices connected and ultimately shuts down any ports that receives a BPDU from any authorized switch. For internal routing, we selected OSPF, an open shortest path first. We choose OSPF because it is an open standard that works within any vendor. It uses a link state algorithm for fast convergence and support passive interfaces to prevent routing traffic from each end users. All layer 3 devices run on SPF process 1 and area 0. You can see, let's click on core switch 1 to fully see this. Once again, enable show IP OSPF neighbor. Oops. Okay. Core switch 1 shows OSPF neighbor is full state neighbor 17.16.255.1.1 is a 1 RTR full state and gigabit 0101. Then neighbor 17.16.255.3 is a core switch 2. This is the core switch 2, a full state via VLAN 99. State means the link state database are fully synchronized and routing is working correctly. We also configure OSPF in all 3 distribution switches. In distribution A 9333.333.1 and distribution B is 333.2 and distribution C is 333.3. Due to the known limitation of packet tracer simulator, the OSPF identity between the distribution and the switch cannot be fully shown here. However, the configuration commands are correct and present in each device's running config and will form full identity on physical hardware. Now let us show the villain SVIS core switch 1 that holds all the 12 villains that act as the intern villain router for the entire Malaysian office. Show IP interfaces brief. And his spacebar to see everything. You can see that villain 10, where's villain 10 here? The villain 10 is, and villain 110, all up, all with their corrected gateway. You can see villain 10 is 172.1610.1, the gateway for the executive management, and villain 50 is 17.60.50.1, the gateway for software development. Notice that villain 10 has no assigned IP. That is our guest villain remaining isolated at layer 2. So now let us check the routing table. Route, spacebar again to see everything. Here's everything. You can see that C here for every connected villain subnet, and O. There's O. O is here for the OSPF link to 1 RTR and O star E2 default route. That is a default route distribution from 1 RTR into OSPF. So every internal devices we can reach the internet, everything. So route summarization is also in place. 1 RTR only advertise a single 1716.00/16 to summarize to Singapore BGP instead of all individual villain routes. So finally, let us confirm this, the passive interface configuration is and brief. So here, all 11 user villain interface are configured as passive OSPF. Hello packets are never sent toward any end devices, only the one uplink and the management villain carry OSPF traffic. This is security and efficiency in best practice. For inter-site connectivity, we choose eBGP, which stands for External Border Gateway Protocol. BGP was the correct choice because Malaysia and Singapore each operate under a separate autonomous system number. So BGP gives us a precise control over each exactly which networks are shared between sites. So cleanly separate internal SPF as recall last time. So and the main from the external routing and supports the future traffic engineering. So let's see each router configuration to see this. So let's go first to one router. Type is enable, show IP, BGP, summary. And second on C, on this router we can see the BGP neighbor 10.255.0.1. That is the external router representing the Singapore HQ in 65,050, which is here, which is this. So let's go back to the configuration to properly explain it. So this states that shows to establish we can see the prefix received. The session has been running almost 2 hours already, confirming a stable BGP connection. So let's show the IP for this. So I show IP BGP. As you can see, the BGP table shows the network being exchanged, our Malaysian Supernet, which is this 17.2.16.0.0/16 is being advertised to Singapore. This single summary covers all the 12 of our villain subnets. We'll also see the Singapore HQ network 10.0.0.0/16 being received from external RTR, which is once again our Singapore HQ. So let's go to our Singapore HQ to see this. So enable, show IP BGP summary, and boom, this is the external RTR, which confirms the BGP session with 1 router at 10.255.0 in as 65,001. Also established with Malaysia routes receives both sides of the BGP session confirming working. So let's go back to the first router. Last time you see this, let us check the routing table on one or two to confirm the default route distribution. So spacebar to see everything. So we can see the static here. You can see the static default 00.00/0 via 203.0 113.1. That is the ISVP internet breakout. The default information originate command on one router, then distributes this into the OSPF, so the all internet Malaysia devices automatically have internet access without needing individual static routes, which is very useful. So now for the final part, let us demonstrate the entire network is working the end-to-end live pings. So we are starting with PC0, which is here. You can see yes, it's connected to access A1, which is in building A on VLAN 10, the existing management network. So that is test it. Let's go to this command prompt to type this ping location. So for test 1, we are confirming PC0 can reach its own default gateway, which is so ping 10.1 applying, which is a good sign. And message received. Successful PC0 can reach its core H1, VLAN 10, its default gateway, local VLAN routing is confirmed. So test 2 is inter-VLAN routing between buildings. So we are pinging to PC2 in building B, which is on VLAN 40 in the IT department. So let's try calling PC2.16.40.10. So 0 loss. So successfully the packet traveled from PC0 up to access A1 to distribution A, was routed by course H1 between VLAN 10 and VLAN 40, then come down to distribution B to building B. Inter-VLAN routing between building A and building B is confirmed. So let's go to test 3, the cross building. So cross building to building C, pinging PC4, which is VLAN 70 sales and marketing department. So let us try pinging it. So ping to 16.70.10. Which is good again. So test 3 is successful. All 3 buildings can communicate through core H1, inter-VLAN routing, and across all buildings is confirmed. So let's try test 4. So intersite 1 connectivity ping Singapore HQ at 10.00.1. So ping 1. It's a good sign. The packet left course H1 was routed to SPF 1 RTR across the BGP link as 65,000, which is seen last time. So for the final test 5, internet connectivity pinging 8.8.8, which is our simulated internet host in external router. Ping. Once again, 0 packet loss. So successfully, the OSPF default route on core H1 directed traffic to one router, which is forwarded via the static default route to the ISP at 203.0.113.1 and reach 8.8.8, which is the internet access for all internal user is confirmed. We also can do a quick visual PDU test, sending a simple PDU from PC0 to building A to PC4 and in building C. So let's get our mail. Put in PC1. Let's connect it to PC4 in building C. As you can see, successfully PC1, PC4 has sent the message.